Hello everyone. So we have already completed radiation, pressure and matter wave. Now today we will study a very important topic, that is photoelectric effect. Okay, so before that let's see something. Okay, so first where this photoelectric effect is coming, because we want emission of electrons. Okay, emission of electrons. For that we are not only using photoelectric effect, we are using many different ways. Among that, one is photoelectric effect. What we are doing in photoelectric effect, we are exposing any surface with the light, okay, photons, and that energy of photons is breaking the bond of electrons and electrons are coming out. That is called electron emission. That is called electron emission. Where we are using photons to take these electrons out, we are calling it photoelectric effect. Okay, again, this is not the only method. You can also use the heat energy. That heat energy can break the bond between the electrons and that electrons can come out. Are you getting my point? So that is known as thermal emission, in which we are using heat energy for the emission of electron. The next is field emission. Field emission means we are using electric field, very strong electric field and magnetic field. So due to this field, that electron is getting force. Okay, a force is acting on that electron. Electron is a charged particle, so whenever there is an electric field, it is getting a force. Okay, so due to that force, that bond is breaking and electrons are coming out. And the fourth one is secondary emission. We are bombarding any plate with the external electrons, external material, so they are coming, colliding, and that is remaining there and another electron is coming out. So we are using secondary, we are saying is secondary emission, because we are using electron, energy of electron, and due to that the electron in the metal plate is coming out. So we don't have to read this thermal energy, field emission and secondary emission. We only have to read photoelectric effect. So let's see what it is. Want to write? Just 1 second, write it. Okay, so what is photoelectric effect? Let's just see what it is. So what we have done, we have brought two bulbs, okay, each of 100 watts. See, you can see here, we have brought two bulbs, each of 100 watt. Both are having 100 watt. And then we have kept the same metallic plate in front of them. Okay, two bulbs of same watt, 100 watt and 100 watt of different companies and something like that. Okay, so we have exposed two identical plates with these two bulbs. What we have seen, in one of the bulb, electron is coming out, and in another electron is not coming out. Then we thought, why it is happening? The energy that we are giving, the power, energy per unit time, that is colliding with the first plate and the second plate are equal. Then why it is happening that from the first plate electron is coming out, whereas from the second electron is not coming out? Then we concluded that the electron, okay, emission of electron does not depend on total energy of the source. I am again telling you, I am again saying the statement, the emission of electron does not depend on total energy of the source, but depends on energy of one photon. Energy of one photon. What it is said that every electron, there are many electrons, yes or no, and they are connected with some bond. So now they are saying that this bond will only break when one photon has that power to break that bond. Okay, two photons, for example, I am taking a very simple example here. Okay, see, a very simple example I am taking. Let this is any metallic plate, in which to break this electron from here, you need 10 electron volt energy. Electron volt is a unit of energy, I already told you in the last class. Now to break this electron from here, the energy that we required is 10 electron volt. The energy that required is 10 electron volt. Now the light that you are giving, total energy is 1000 electron volt. Total energy is 1000 electron volt. But the energy of one photon, the energy of one photon is only 8 electron volt. Is only 8 electron volt. Now what it is said that one electron can take energy from only one photon. So at the one time, how much maximum energy it can take? Only 8 electron volt. And how much it is required to break the bond? 10 electron volt. So tell me, this electron will come out or not? You will say, no sir. The energy that one photon is giving is only 8 electron volt. And the total energy required to for the emission of this electron is 10 electron volt. So this electron will not come out. In the second situation, you have applied the same energy. You have applied the same energy, 1000 electron volt. Okay, and the energy required to bring this electron out is 10 electron volt, and the energy of one photon, here is 11 electron volt. Now what will happen? This 11 electron volt, that electron will get 11 eV. Now how much energy is required to break? 10, but how much he is getting? 11. So this electron will come out. Are you getting my point? Are you getting my point? This photon is useful, okay, and this electron is not useful. Now if that 8 electron volt photon is not useful, then either you just bombard 1 or 1000 or lakh or 1 crore. Is it any beneficial for us? No. But if that electron, if that photon is useful, then it will bring that electrons out. Are you getting my point? How much electron has came out? How much electron has came out depends on total energy. Depends on total energy or power, you can say. But the electron is coming out or not does not depend on total energy. Are you getting my point? Don't worry, everything is written here. You can write it down. Just listen to me and just think what I am saying. Emission of electron does not depends on total energy, but it depends on energy of one photon. It depends on energy of one photon. Are you getting my point? One electron can get energy at a time from only one photon. It will not happen that two photon combining and bringing one electron out. No. That is not happening. Only one photon is responsible for bringing one electron out. Are you getting my point? All these things. Now, this 10 electron volt, that is the minimum energy required to break the bond. And here example I have taken 10 electron volt. This minimum energy required to break the bond, we call it work function. What we call it? Work function. Minimum energy required to break the bond is known as work function. Are you getting my point? Also denoted by phi. So what we will say, for example, here 11 electron volt, 11 electron volt photon is coming. That electron has this out of this 11 electron volt, 10 electron volt has been wastage in breaking the bond. Now how much is left? 1 electron volt. So this electron will, when it will come out, it will have kinetic energy of 1 electron volt. Are you getting my point? So if total energy of photon is E, total energy of photon is E, so it will be phi amount of energy will get waste in breaking the bond. Are you getting my point? E is the total energy that you have given. Phi is the work function, minimum energy required to break the bond. Okay, so the rest one will be kinetic energy of electron. So remember this formula, E is equal to phi plus kinetic energy. But when this is applicable, when electrons are coming out, when E is greater than phi. Only when E is greater than phi, at that time you can say that electron emission will take place. And when E is less than phi, what you will say? Electron emission will not take place. And when electron emission is taking place, you can say that E is equal to phi plus kinetic energy, where E is total energy of one photon, hc by lambda. Phi is the energy required to break the bonds, plus kinetic energy is the excess energy that any electron is getting. So if you want to write, you can write some things here. See, I have told you this. See on the screen, photoelectric effect does not depend on total energy of light, but depends on energy of one photon. Only board is visible now. Photoelectric effect does not depend on total energy of light, but depends on energy of one photon. I have already told you this. Minimum energy that is required is called work function. Minimum energy that is required is called work function. For emission, if your total energy is greater than work function, here I am written it in terms of W, or you can write it as phi also, then only your electron will get emitted, otherwise it will not get emitted. See, now this energy, what you can write it as F. This energy or work function that you are saying now, work function or phi can be written as H into vu naught. Okay, that means frequency. This is frequency, threshold frequency. We also call it as a threshold frequency. Minimum frequency of photoelectric effect is known as threshold frequency. The minimum frequency that is required, for photoelectric effect, that means for emission of electron, is known as threshold frequency. Are you getting my point? Phi is the energy. Energy can be written as hc by lambda or h v naught, or you can write it as hc by lambda naught. Threshold wavelength. Are you getting my point? You will get this v naught, threshold frequency. You must know what is threshold frequency. Is the minimum frequency required for photoelectric effect or emission of electron. I think this is all is clear. I already told you about this, the formula. E is equal to phi plus kinetic energy. Energy can be written as H into F. What is F? F is the frequency of the light that is coming. What is F naught? F naught is the minimum frequency that is required for photoelectric effect, and kinetic energy you know. So what you can write, kinetic energy is equal to H F minus F naught. You can write this equation. Are you getting my point? So this is the basic thing that you must know, you must understand. Now there is only some formulas and very small things that I will tell you about from exam point of view, and this all will get clear. So first, before studying that electric potential and what are the experiments that we are doing on this theory, you must know what I have told you right now. That when electron is coming out, why electron is coming out, with how much kinetic energy it is coming out, what is threshold frequency, what is threshold wavelength. Are you getting my point? So you can write it down this whenever you require. You can pause the screen and you can write it down. So now let's see the experiment. Okay, now just try to understand what I am saying. When that photons are coming, striking into a plate, electrons are coming out. Now this electrons is not having that maximum kinetic energy that we talked about. All of the electrons is not having. Some of the electron is having that maximum kinetic energy, but some are having zero kinetic energy also. So this energy distribution graph is distributed from 0 to the maximum. What will be the maximum? We have already seen that maximum kinetic energy is total energy minus work function. That will be the maximum kinetic energy of the electron. Are you getting my point? There it is written as kinetic energy maximum. What does that mean? The maximum kinetic energy that any electron can have during photoelectric effect is that kinetic energy maximum. That is H F minus F naught. Is that clear? Now why it is happening that all of the electrons is not having that same kinetic energy? Because when electron is coming out, they are also colliding with each other, so they are losing some energy. Okay, so that is nothing more explanation in that. The only result that you have to remember is the electrons that are coming out is having all the energy 0 to maximum kinetic energy. Are you getting my point? Okay, now in this experiment what we are doing, as you can see in this there is a tube in which there is there is a material, target material, in which light is coming. We are imparting light on that. Now what is happening? Electrons are coming out. Some of the electron that is having maximum kinetic energy is able to reach the other point. Some can only reach till here, some can reach till there, some can reach till here, and even some can only stop there only, having zero kinetic energy. If zero kinetic energy, then they will stop there only. Are you getting my point? Now what will happen, and this type of arrangement is done. Potential difference, for potential difference, a voltmeter is there, ammeter is there, ammeter is there, and a battery is connected like this, such that at this point potential is 0, at this point potential is negative, and at this point potential is positive, and you can slide it. That means when you want negative potential, you can slide it at this point, left hand side, and when you want positive, you can slide it on right hand side. Are you getting my point? All of these things. Now what is happening? When you have not applied any potential, then there will be some current. there will be some, when photoelectric is happening, that time I am talking about when you haven't supplied any potential. Again I am telling you, when you haven't supplied any potential, at that time some electrons are coming, so some current is there, some current is there. Now if I increase the intensity of light, if I increase the intensity of light, number of electrons that is coming out will increase, number of electrons that will coming out will increase, so current will increase, more charge will flow now. If more charge will flow, then current will increase. Are you getting my point? If I decrease the intensity, then current will decrease. So first thing that we are getting is, the first thing that I can say you, intensity is increasing, then current is increasing. Intensity is decreasing, then current is decreasing. This is clear, and this is only possible when your photon is useful, like photons. When your photons is useful, then only you can say this. When H is greater than, no, when F is greater than F naught, or you can say that when energy is greater than work function, then only we are talking about. We are only talking about the useful photons. When you are imparting useful photons, at that time if you increase the intensity, then current will increase. If you decrease the intensity, then current will decrease. Is that clear to everyone? Is this clear? Now what will happen? Till now we haven't supplied any potential. Now if we supply a positive potential means, what does this mean? Positive potential means this one will be positive and this one will be negative. Are you getting my point? We are supplying positive potential. We have slided it towards right, positive potential. So this end will be positive, this end will be positive, and this end will be negative. Are you getting my point? Now electric field will be in which direction? From positive potential to negative potential. Let me draw it here for you. Okay, try to understand what I am saying. Try to understand what I am saying. Okay, till now it is clear. When no potential difference, when nothing is there. Okay, so when you are increasing the intensity, current is increasing. When you are decreasing the intensity, then current is decreasing. Now what will happen? Now in this, you have applied positive potential like this, positive. So this one will be positive, this one will be negative, and electric field will be in this direction. And here is electrons. Electron is negative charge. If positive charge is there, then it will be having a force in direction of electric field. But negative charge particle is there, so it will have a force in opposite of electric field, in the direction opposite of electric field. So this electron will have force in this direction. Okay, now what will happen? Maybe initially what is happening when no potential difference is there, 100 electrons are coming out. Initially when no potential difference was there, 100 electron was coming out of which only 10 electron is having that kinetic energy such that it will reach to the next part. Are you getting my point? That it can complete the circuit. Are you getting my point what I am saying? So at that time only 10 electrons are coming, so current is according to that. Now what you are doing, you are applying an electric field due to which this electron is having a force in this direction, in right direction. So the electron who is not having that much kinetic energy also will now start moving towards the what? Towards the positive plate. Are you getting my point? So the current will increase. So when you will increase the potential, when you increase the potential in positive, what will happen? Current will increase. Before only out of 100 electron was coming out of the plate, but only 10 was able to reach. Now you are helping that electrons to come. You are just pulling it. You are what you are doing? You are pulling it. Now more electrons are coming. More electrons are coming. That means current will increase. So now what will happen? Now what will happen? If V increases, potential increases. When potential increases, then current also increase. When potential is increased, then current will also increase. Are you getting my point? But till one limit, when you are increasing the potential, electrons are coming more. But total how many electrons are coming out of the plate? 100. For this example, only 100. So after one time, all these 100 will reach to the positive plate. After that, current will not increase. Are you getting my point? Till one limit only current will increase. After that, current will not increase. Are you getting my point? If V increases, then I increases only till some limit. Only for some limit you can say that when potential you are increasing, then current is increasing. Don't worry, don't worry. When I will make the graph, everything will be clear. Is that clear? When no potential is there, understood? When no potential was there, understood? When positive current is there, how it is behaving, it is understood. Now we will see about the negative current. Now we will see about the negative current. Okay. Negative means this one is positive, this one is negative. Now again 100 electrons are coming out of which only 10 electron is able to reach this point. Are you getting my point? Same example I am taking. This is just an example. I am not talking that 100 electron is coming out. Okay, just an example. If 100 electron is coming out of which only 10 was able to reach the point. Now what you have done? You have applied the electric field in this direction. So this electron will have a force in opposite direction. Now this electron is trying to move in that direction, but you are pulling it opposite. So what will happen? Now if you increase this potential in negative, maybe initially 10 electron was coming. Now what will happen? 9 will come. You will increase more potential. Now only 8, 7, 6. So you can increase this potential, negative potential. In minus V, you can increase it such that the maximum kinetic energy electron is also not able to reach that point. Are you getting my point? All of the electrons are coming out with different kinetic energies. Okay, so you are applying that much potential, negative potential, such that maximum kinetic energy electron is not able to reach the opposite point. Is not able to reach the opposite point. At that time, no current will flow. At that time, no current will flow. So what is happening? Now, what is happening when V is increases? When V is increases in negative, minus V is increases. In negative, when V is increases, then current is decreasing. Current is decreasing. For some minus V, I becomes 0. This word potential is known as stopping potential. Are you getting my point? Everything is very simple. When no potential is given, some of the electron is coming. When you are increasing the potential in positive, more electrons are reaching. When you are decreasing the potential or increasing the potential in negative, opposite direction, what is happening? Electrons that is reaching the another plate is reducing. And for one potential, no electron is reaching. That means current is 0. That potential is known as stopping potential. That potential is known as stopping potential. Are you getting my point? Are you getting my point? What will be the stopping potential? First I will tell you this, then two graph, then complete photoelectric effect. Are you getting my point? If you are just doing this as a revision, you can increase the speed. There is an option to look the video in 1.25 speed, 1.5, 1.75 and 2, whatever you like. Okay, although my speed is little bit fast because this is just a crash course for you all. Okay, so let's see what is stopping potential. The energy you are supplying is equal to work function plus kinetic energy. Is equal to work function plus kinetic energy. Now you are supplying the potential. Now you are supplying the potential. See here. When you have connected this plate, this is at 0 potential. So point this will have 0 potential. Is that clear? And this point will have potential V. So energy of electron at this point will be 0. Energy is charge into potential. I am again telling you, if you don't know, just see. Charge into potential is known as potential energy, electrostatic potential energy. If you don't know, I am telling you, although I will give you the very short lectures of electrostatics also, don't worry, each and every chapter I will provide you. Are you getting my point? Okay, so this potential is 0 and this potential is V. So energy of this point is 0 and energy of electron at this point is EV. Are you getting my point? So now conservation of energy. Electrostatic energy is a conservative force. Electrostatic force is a conservative force. So we can apply conservation of energy, mechanical energy. Are you getting my point? That means total potential energy plus kinetic energy is equal to total potential energy plus kinetic energy. What we are calculating? Stopping potential. Stopping potential means the electron that is having maximum kinetic energy is also not able to reach, or just reaching. Are you getting my point? So this electron is having maximum kinetic energy, at this point kinetic energy is Ke plus potential energy is Ev. Are you getting my point? Now at the final, at this destination, potential energy is 0, and what we want at this point, its kinetic energy will also become 0. So see, Ev is equal to minus kinetic energy. So V is equal to minus kinetic energy by E. Always remember, this kinetic energy we are taking in Ev. Then you will get the stopping potential. See, negative sign is coming. That means negative potential is required. Can you remember this? That what is the stopping potential? Minus times kinetic energy of E. Kinetic energy by E. And kinetic energy you have to calculate in electron volt. Are you getting my point? Sure. Now, just drawing one graph. Be careful. See, concentrate with your 100% presence of mind. Ting, 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 ting. Okay, what is happening? See, at this I am taking potential and this I am taking current. When potential is, we are only talking about photoelectric. When photoelectric effect is taking place. Okay, when useful photons are coming, we don't require a non-useful photon. So when useful photon is coming, when there is no potential, there is some current. Are you getting my point? Now what is happening? As you are increasing the potential in positive, current is increasing. But after some time it is becoming constant, because all the electron that is coming out is reaching. Now from where new electron will come? Are you getting my point? So what is happening? This is increasing but then becoming constant. We call this current as saturation current. Saturation happened. Now it will not increase. Are you getting my point? This current is known as saturation current. And what is happening when you have applied potential in negative? Current is reducing. And for some potential current is 0. This potential is known as stopping potential. Saturation current. Are you getting my point? Is this graph clear? When potential is 0, current is something. When potential is increasing, then current is increasing till some limit. And when potential is decreasing in negative it is increasing, you can say, at that time current is decreasing. And for some potential, negative potential, current is 0. That potential is known as stopping potential. Are you getting the feel what is happening everything? Okay, 1-2 graphs or more. Let's see, just see this. Okay, so let's see some questions, 2 or 3 questions, let's see, and then we'll end it up, and then we will start atomic structure. Okay, atomic structure after this. Ratio of kinetic energy maximum for two different wavelengths, lambda 1 and lambda 2, is eta something, this is given. Okay, that ratio of ratio of kinetic energy maximum kinetic energy of two different wavelengths, lambda 1 and lambda 2, is eta. Find work function on same surface. On the same surface, what will be the work function? Pause the screen and attempt. Attempt is very important. I'm telling you, just think what is the answer. Then I will tell you. I am here only with you. I already told you. Okay, pause the screen and attempt. I am telling you the answer. See, for first one, what you can write is Ratio of kinetic energy of two different wavelengths lambda 1 and lambda 2 is eta. For first one, what is happening? Hc by lambda 1 is the total energy that you are giving, will be equal to some work function. Some energy is lost in work function plus kinetic energy maximum 1. I am telling about the lambda 1. Kinetic energy corresponding to lambda 1 is kinetic energy maximum 1. Similarly, Hc by lambda 2 is the total energy that you are giving from second wavelength, will be equal to phi. Work function is same. Work function is same now on the on same surface for two different wavelength. The kinetic energy ratio is eta. It is given. Are you getting my point? So this work function is same for both. For lambda 1, total energy that you are giving is Hc by lambda 1. For second, total energy that you are giving is Hc by lambda 2. So kinetic energy maximum 2. So what it is said, kinetic energy maximum 1 upon kinetic energy maximum 2 is equal to eta. So what will be kinetic energy maximum 1? Kinetic energy maximum 1 will be Hc by lambda 1 minus phi. So what we will say, Hc by lambda 1 minus phi upon Hc by lambda 2 minus phi is equal to eta. Just multiply it. What we will get? Just multiply this. Just multiply this. What we will get? Hc by lambda 1 minus phi is equal to eta Hc by lambda 2 minus eta phi. Okay, what do you want? Eta. So just bring this minus eta phi here. You want phi na? Work function. What is it is asked? To find the work function. Then what we will write? Work function common, eta minus 1 is equal to, I think Hc is common. Hc is common, eta by lambda 2 minus 1 by lambda 1. Simple. So phi is Hc and lambda 1 minus lambda 2. Just multiplying this, cross multiply upon eta minus 1 into lambda 2 lambda 1. This is your answer. Whatever answer you are getting, but the concept is this, that what it is written, total energy that you are getting is Hc by lambda 1, out of which some energy is lost as to break the bond, that is known as work function. That is only asked, that phi is asked. So two equation, two unknown, you can calculate the answer. Are you getting my point? Are you getting my point? Actually, three equation and three unknown. Kinetic energy 1, kinetic energy 2 and phi. 3 are the unknown and 3 equation is there. 2 equation is this and 1 equation is kinetic energy 1 upon kinetic energy 2 is equal to phi. 3 equation, 3 unknown, you can get all the things that you want. Okay, simple mathematics. If I have done something wrong also here, it's just you to look into the calculations. Are you getting my point? This equation, if you are writing, then all the concepts are clear. If you are able to write this equation, then all the concepts is clear. Okay, just see the next question. If we double the frequency, comment on kinetic energy max. Becomes double, more than double, less than double. When you double the frequency, for example, for some plate, some energy is coming and there is some kinetic energy, maximum kinetic energy of electron. So now when you double the frequency, what will happen? This kinetic energy will become double or more than double or less than double. That you have to tell. Tell. Fast. Attempt. I'm very small, no? Let's become big. Again small. Okay, now let's see. Initially, let hf, initial frequency, is equal to some work function plus kinetic energy 1. I am talking about kinetic energy 1. Now what you have done, this is the initial equation. You can write total energy equal to work function plus kinetic energy. Total energy is equal to work function plus kinetic energy. Now you have doubled the frequency. So what it will happen? 2hf will be equal to work function is same plus kinetic energy 2. Now we have to compare kinetic energy 1 and kinetic energy 2. From these two equations, can I remove the phi? Phi is same. So what will write? hf minus kinetic energy 1. hf minus kinetic energy 1 will be equal to 2hf minus kinetic energy 2. So kinetic energy 2 is equal to kinetic energy 1 plus hf. Are you getting my point? So see which is more. Or you can write it as like this also. Kinetic energy 1 can be written as See, from here kinetic energy 1 can be written as HF minus phi. Kinetic energy 1 can be written as HF minus phi. So if you write it here, what it will become? See, here it is right now, kinetic energy 2 is equal to 2HF minus HF is HF. Okay, everything is correct. Now kinetic energy 2 is equal to, instead of kinetic energy 1, what you can write? Instead of kinetic energy 1, what you can write? Okay, instead of HF, you can write phi plus kinetic energy 1. So it will become kinetic energy 1 plus kinetic energy 1 plus phi. So it will become kinetic energy 2 is equal to kinetic energy 1, 2 times kinetic energy 1 plus phi. So see, double, more than double. Phi is some positive, phi is some energy that is required to break the bond. So phi is some positive. So kinetic energy 2 is more than twice. Initial kinetic energy is kinetic energy 1, so double plus phi. So that means kinetic energy now is more than double of initial. More than double of initial. Are you getting my point? Again, I am telling you, there is only one question. Other is only simple mathematics calculation. If you are having a practice of solving the questions, of thinking how many ways we can go, it's very simple. It's very simple. Are you getting my point? So now, simple, it is looking kinetic energy 2 equal to 2 times kinetic energy 1 plus phi. 2 times kinetic energy 1 plus phi. Here what I have done is, I have written HF. What is HF? Phi plus kinetic energy 1. This value I have kept here. So I got the answer. Are you getting my point? Last question for this. Again one. Draw graph of F, frequency and kinetic energy max. F is the frequency that you are supplying of the light, photons, and kinetic energy maximum is the maximum kinetic energy of the electrons that are coming out. So what you will say? Pause the screen and attempt. I am again telling you, every time pause the screen and attempt, and then only look into the answer. Okay, so what I am saying is, HF is the energy that you are supplying is equal to work function plus kinetic energy maximum. So what you want? Graph between F. What do you want? Graph between F and kinetic energy maximum. So let us take, this is F and this is kinetic energy maximum. Let's see. Now for some F, we know that photoelectric effect will only occur, this electron will only come out when this F is more than some F naught. So till F naught, there will not any electron, no electron will come out, so they will not have any kinetic energy. Now what will happen? Now if you increase the F, your kinetic energy will increase, and this is a constant, so it's simple. Y is equal to mx plus c. A linear equation is there. Y is equal to mx plus c. A linear equation is there. See, your y is F. Y is sorry. Your kinetic energy is y and F is your x. So what you can say? Kinetic energy maximum. That means y is equal to HF. This is your m. F is your x. HX. H is your m. HX plus minus phi. Are you getting my point? That means your C is negative. That means graph will intersect in negative. So this will be your graph for some metal. Are you getting my point? What is your slope? Your slope is h, and that means slope is constant. Remember, graph we have done. Now I am talking something extra about this. Very important. Just remember, when you are drawing a graph of F and kinetic energy max, you are getting a straight line. And slope of this straight line is h. Which is constant. If you take another material, this F naught will change. But slope of all three will be same. Are you getting my point? Okay, tata, bye bye.